Hello everyone, thank you. I'm Alexandros, I come from Greece, and today we'll be talking about cold ironing or onshore power supply as part of the electrical report project funded by the European Commission. We'll start with the introduction, background, and then focus on the Heraklion report where we will do the case study, then conclude them. So what is onshore power supply or cold ironing or onshore connection? Shore-to-ship power or alternative maritime power is the procedure of providing power from the electrical network, the main grid, to the ships berthing at ports. And this has important benefits as the ports are most of the times located very close to the city center of major cities. We see a very similar example in the city that we're here in Valletta. We have very big cruise ships berthing very close to the city. And this means that when they use their onboard diesel generators, they have important emissions that are directly fed into the area that a lot of people live. So onshore power supply is expected to be a decisive movement towards the reduction of emissions, and especially close to major cities. And at the moment, USA and China have already included into their regulations, while the European Union is expected to do by 2025, by requiring all of the new ships to have the capability for onshore power supply. So the advantages are the elimination of the emissions as we discussed and the better air quality close to the nearby areas. However, there are significant challenges to tackle, like the capacity of the distribution networks, which in many cases is not enough to cover all the ships berthing at the port, and of course the financial feasibility as we're talking about very large and major installations. This is what we're planning for the port of Heraklion, and maybe as you're aware, it is a touristic destination. That means that we'll have many ships coming every day, and especially during the summer period. Here you can see that we have 3 ships every day going to the Cycladic Islands, Santorini, Mykonos, maybe you know some of them. We have 2 big ferries going every night to Athens, and then we have 2 or 3 cruise ships every day, and 4 or 5 container ships berthing at sometimes at the same port. And just to emphasize why cold ironing is challenging, imagine that the small ships going to the Cycladic Islands, when they are at the shore, at the port, they require 500 kilowatts each one, and then going to the ferries going to Athens, 1.5 megawatts each one continuously, and going to the cruise ships up to 3, 4, 5, and 15 megawatts, which is the ship that we saw also on the first day when we were cruising, which was a very large cruise ship. This actually requires 15 megawatts at continuously. And how is this addressed? This is addressed by a medium voltage distribution network into the ship, and where the ships berth, we have the installations with an isolation transformer, and according to the capacity of each ship, we can either have a portable cable reel or a portable cable management system for the ro-ros, which are of greater capacity. So what happens in the literature? Cold ironing is very much researched and investigated, and its power demand as well as the pollution that it creates for the close by area is very much researched and investigated. Also, how renewable energy sources can support the operation of onshore power supply is investigated, while also the limited space that we have in the ships to do such installation like renewable energy sources is also taken into consideration. However, there is not so much research on the topic of the limited power, the limited energy that the distribution system can provide in such installations. This is an exemplary case of what are the average emissions per megawatt hour for the power system of grid, and this is the estimated average emissions per kilowatt hour for the onboard generators of the ships berthing at Heraklion. And to simplify this, we can see that when we take into consideration OPS, onshore power supply, for all the ships, we can achieve an emissions reduction ranging from 65% up to 96% according to each pollutant. So it becomes a very important problem to tackle. What we did in this study is we investigated how a hybrid power plant could support the operation of OPS by reducing the requirements for power capacity of the grid. So taking into consideration the constraints that the power that we can receive from the grid is limited below a value per grid max, and the battery energy storage constraints, and considering that the battery would charge in 3 hours and discharge accordingly, we did an exhaustive search algorithm to find the minimum battery energy storage system requirements for a combined battery energy storage system and PV plant with a certain area available in our port. And we also assumed a specific, we also assumed a specific loading where you can see that in the summertime, when we have the cruise ships, the load goes below 15 megawatts, and we took some real data with regards to the production per kilowatt capacity, installed capacity of PVs. And 2 scenarios were considered. The one assumed that even though our port requires around 16 megawatts of loading, this is not viable by the distribution grid operator, and they can allow between 13 or 14.5 megawatts. While the second scenario assumes that the distribution grid has a capacity of 13 megawatt, even though we have a requirement for 16 megawatts, and the range of installation, the area for this plant ranges from 4,000 to 8,000 square meters. For the first scenario, we saw that by when increasing the grid capacity by 0.5 megawatt, the best capacity was decreasing by 3.3 megawatt hours and the PV capacity by 5 kilowatt peak. However, you can see that even for reducing by 2 megawatts, the maximum load that the onshore power supply that the ships need, we are leading to a very high battery energy storage system capacity, and this makes the financial feasibility study of this very interesting. Although note that the whole project goes in installing OPS may go above 10 million euros, so this may not be the most considerable cost in creating such an installation in the port. On the other scenario, we assume that the grid can supply 13 out of the 16 megawatts that our maximum load is, and we have a variable area that we can use from 4,000 up to 8,000 square meters. And you can see how the battery requirement drops as more and more PVs can be employed and minimize the capacity of the battery. Why we selected to minimize the battery in this problem, also taking into consideration the available area, was that our thinking that the battery energy system would be more complicated for the Port Authority to use it, while the PVs are a more straightforward investment with more a clear operation for them. So in this study, we investigated the concept of hybrid power plants as a remedy for the major issue of onshore power supply, which is the required high peak demand, which in many cases the distribution system coming around the port cannot cover. We also showed a simple method of how to size the PV panels and the battery storage system of a Seaport microgrid with OPS capability. This took place in a real study that takes place in the electrical port project, where we are doing all the design for the cold iron installations that will start in the next year in practice. And we are also working now towards the financial feasibility to see if it's better to use the storage devices rather than increase the requirements you have by the distribution system, which could mean that you would need to install new distribution lines in order to allow that. And before closing, let me thank my industrial partners, especially Wartsila, leading expert in the field, and also the Heraklion Port Authority for the collaboration with us. Thank you.
Please, any questions?
Because we have a little more time. Is any demand side flexibility on projects like this?
Yeah, so for example, you know, a ferry going every night from Crete to Athens, they would stay from 9 o'clock in the morning up to 9 in the night in the port berthing. But because if they close the air conditioning system, yep, the ship will become very hot, okay, they never close it. So, so all day they require 1.5 megawatts for running an air conditioning system, which actually nobody needs at the time. But this would significantly reduce the requirements for energy from the grid, and it would make our life easier. But it's a bit different to change the status quo in such an industry, so there are discussions, but let's see how this will go.
Thank you.
Thank you.
We have time because so maybe if there's any other question, please. No. So I think that's all for this presentation. Let's give a big hand.
Thank you.